this video, we're going to look at how to calculate distance along a map. And there are two different ways in which you can calculate distance. Firstly, either with a straight line distance, and this would be from point to point as the crow flies, or curved distance, which is generally along a route that a car would maybe drive along a road. You would possibly be walking along a hiking trail or a boat going down a river. And so that is your curved distance. With both of these, we need to understand that you're measuring a distance on a map using centimeters, and then we need to scale that distance on the map up into reality depending on the actual scale of the map. So if your map is a 1 to 50,000 map, it means that reality has been shrunk 50,000 times to fit on that piece of paper. And so 1 centimeter on the map represents 50,000 centimeters in reality. There are two methods that one can use to work out distance. And this is the longer method, where you times it by the scale and then convert it into either kilometers or meters, or you can just go straight into the shortcut. And for each of the worked examples, I will show you both methods, as it is important to understand the full long method in case you are not able to use the shortcut with the specific scale that you are given. Our first example says calculate the distance from trig beacon 89 in B5 to spot height 1088 in B5, and this is in kilometers. Now, if a question doesn't tell you whether it wants kilometers or meters, the rule that you need to apply is that if the distance is greater than 1 centimeter in terms of what you're actually measuring on the map, then convert automatically to kilometers. Anything less than a centimeter, so say your distance was 0.5, then you can just convert it to meters. And that can be a standard rule that you can apply. Our first question says we need to calculate the distance from trig beacon 89 in B5, so that is trig beacon 89, to spot height 1088 in B5 as well. So that's the spot height, and there's the trig beacon. And the rule that I always follow, just to try and standardize and make the process a lot easier, is to always measure from the middle of a feature and keep that standard across all types of symbols. Get your ruler, and it might sound like an easy thing to do because we've all been using rulers since grade 1. But some of us are getting confused with the millimeters still. So make sure you understand that even though you're measuring in centimeters, you're using the millimeter side so that you can then say with a decimal how many centimeters you're actually measuring. So then this would obviously then be 1.5 centimeters. So make sure you're familiar with how to read an actual ruler. We're going to start off by measuring the distance from the one to the other, and I always find it helps to use a see-through ruler because then you can see your features clearly through the actual ruler. A line up from the middle of the trig beacon to that spot height and read off the exact height in centimeters. I'm going to get a little closer view there so that I can see it more clearly. And I've got 2.7, I would say 2.7 centimeters. Right, now that we've measured the distance of 2.7 centimeters, that is obviously the distance on the actual map, and we now need to scale this up into reality. So in order to do this, because we used a 1 to 50,000 scale, we're going to times it by 50,000. We're going to blow it up by 50,000. And 2.7 times 50,000, and I always use a calculator to make sure that I don't make silly mistakes, is 135,000 centimeters. Now that is the answer. However, you would never explain a distance to someone by saying, I'm 135,000 centimeters away from you. And so it's important to convert this distance into a more useful unit. And so you need to divide that by either 100,000 for kilometers or 100 for meters. And in this example, we want kilometers. So we're dividing by 100,000. And the understanding here is that you have to divide by 100,000 because there are 100,000 centimeters in 1 kilometer. And when we divide that by 100,000, we get an answer of 1.35 kilometers. Now, if I wanted to do the shortcut, all I would have to do is take the same distance that I measured on the map, and because I'm using a 1 to 50,000 map, if I want kilometers, all I have to do is take my centimeters and times by 0.5. And I will get the same answer, 1.35 kilometers. So in essence, instead of taking your answer and timesing it by the scale and dividing by 100,000, we have just jumped to timesing by 0.5 to get the same answer. Our next example says calculate the distance of the runway in C4 running north-northeast to south-southwest in meters. So if you find the runway in C4, you will see that it crosses over like that. So there's two paths, and the path that we're focusing on is the one that is running from the north-northeast to the south-southwest. So that is the line that we are going to measure to work out our distance. Okay, I'm going to use my ruler and line it up very carefully. And I can see that that is 6 millimeters, and so we're going to record it as 0.6 centimeters to make sure that our distance constantly is recorded in centimeters using our ratio scale, which is in centimeters. So now in terms of the long method, what we're going to do is we're going to measure that distance and we get 0.6 centimeters. We take 0.6 and we times it by the scale to blow it up. Okay, on the calculator, 0.6 times 50,000, and we get 30,000 centimeters. Obviously, we want to give this in a more realistic unit because it would be quite strange to explain to a pilot that he needs to account for a 30,000 centimeter runway. And so we need to divide now. But because we're using meters in this example, the rule says that if you are dividing into meters, you have to say divide by 100 because there's 100 centimeters in 1 meter. So I'm taking my full answer, dividing that by 100, and I will get my answer then in meters, which is 300 meters. So the runway is 300 meters long. The shortcut would be 0.6 centimeters, and we times that straight away by now not 0.5 because we want to use meters, but by 500. So 0.5 times by 500 gets me 300 meters. And again, we are not timesing by timesing by 50,000 and then dividing by 100. We're just skipping and going straight to timesing by 500 to get the same answer. When measuring a curved distance, I like to use a divider. And in order to do that, what you need to do is take your ruler and set your divider to exactly 0.5 centimeter. I find that is the distance that works best on a 1 to 50,000 map. And you need to make sure that when you align it, you need to ensure that the divider points are exactly on the 0.5 millimeter mark from the start to the end. Because if you add an extra millimeter, each step will be a millimeter bigger and you're adding quite a bit of extra distance on your calculation. So once you've set it to 0.5 centimeter, you then need to count the number of steps that you can take between your 2 points. My first point is benchmark 786.9 in C2, and my ending point is the intersection with the R63 in B3. And I'm going to count the number of steps that it takes for me to go from the one point to the other. Be very careful not to adjust the actual size between the two divider points, and possibly you need to use a screwdriver to tighten the actual divider to make sure that these are not loose. I always hold it at the top and then pivot and turn alternating each step. So I'm going to start on my benchmark and take 1, 2, 3, 4, alternating each side, 5, 6, 7, 8, 9, 10, 11, and to the intersection, 12 steps. Right, and we measured the distance from along that route as 12 steps. So let's start with the long method. With those 12 steps, each step was 0.5 centimeter in size, so we times that by 0.5 centimeter. And I keep using my units throughout to remind me what part of the step I'm actually on. And that then gives me 6 centimeters. Now I have a distance on the map, and I can take those 6 centimeters and I can times it by the scale, times by 50,000. That will then give me 300,000 centimeters. And obviously this is the answer from the benchmark to the intersection, but we need to put it into kilometers to make it a more useful unit. And the question didn't ask for kilometers specifically, but because the question or the distance was greater than a centimeter initially, we're going to automatically use kilometers here. So I'm going to take my answer and divide it by 100,000, and that will then give me 3 kilometers as my distance. The short method, again, you had 12 steps. You're still going to times by 0.5 because each step was 0.5 centimeter in size, and that still gives you 6 centimeters as an initial distance on the map. Now we're going to do the shortcut and times straight away by 0.5 again, and that will give me 3 kilometers. What's important to notice here is that we have times by 0.5 twice. Once, the first time, is to actually see the distance between the steps and to get rid of the steps and put it into centimeters. The second time is the shortcut to actually go into kilometers. So don't be confused and only times it once. In this example, we want to work out the perimeter of the golf course, which is obviously then going around the outside boundary of the entire golf course. So this is a curved distance that we're going to calculate. Again, I'm going to set my divider to 0.5 centimeter, and I'm going to start along the one point of the actual boundary of the golf course and make sure that I go all the way around and end at the same point. Counting my steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there seems to be a 0.5 step left, so you can call that 11.5 steps. In our second example, we measured the perimeter of our golf course as 11.5 steps. If I take those 11.5 steps and I times it by 0.5 because that's the size of each step, I get 5.75 centimeters. Now we take 5.75 centimeters and we times it by 50,000 to blow it up into reality. That will then give us 287,500 centimeters. Now, if we had to ask for fencing and we wanted enough fencing for the entire perimeter of the golf course, and we asked for 287,500 centimeters of fencing, I think we would get quite a skew look. So we need to divide this or convert it into kilometers or meters. Now, the question specifically has asked for meters, and so we're going to divide here by 100. And that will then give us an answer of 2,875 meters. The shortcut, we would take 11.5 steps, and each step again was 0.5 centimeters, and that would give us a total of 5.75 centimeters. We take that and times it automatically by 500 because we're doing meters, and it gives us the same answer, 2,875 meters.